Good morning, and thank you to the Academy. Thank you to David for inviting me today, and thank you, Harvey. That was an absolutely fantastic talk, but also quite daunting to follow. So I'm going to give a talk, but if I've never really given before. So to help me as much as you, I thought I'd provide an outline. I'm going to talk about my journey. I'm going to talk about the what's, the whys, and the why nots of clinician science, and provide some career highlights to really guide that process, and also talk about my mentors and role models, and then some tips and advice for aspiring clinician scientists. So to start at the very beginning, I was born in Aden in Yemen. My father came from India. He came from a very, very poor family. He was the first person to go to university in his family. He needed a scholarship to go to school because he came from a poor village, and they had to have a village meeting just to decide whether they should allow the first person from that village to actually go to school. He became a lawyer, and he went to Yemen and met my mother. So she was very different. She actually came from a very wealthy family, but being female, she was disinherited, and she was also not educated. And to this day, she can't read or write. So I was born in Aden, which was at that time a British protectorate. Just like now, there was a lot of violence in Yemen, so they decided to move. And the options were to go back to India or to go to the UK because of the British protectorate situation. That would mean that my father would have to give up his law practice, which he did. And for the sake of his children's education, we moved to the UK. And I lived above a shop, a bit like this lady here. And I grew up in Thatcher's Britain. And I grew up in an industrial town that was made famous a few years ago by this movie here, Blinded by the Light, which was set in the same sixth form college that I went to, and was set 3 years after I'd left it. And that film, it's a feel-good movie, but there's a lot in that film that resonated for me. It was a time of great strife, a lot of race riots. I think the intergenerational tension certainly resonated with me as well. But another thing throughout my education was that every year we did these aptitude tests to see what our career should be. And every year I got exactly the same results, which is I should either be a journalist or I should do medicine. And I chose medicine. So we've done the first part of my journey, and then I did specialist training, having finished medical school. And I decided to do haematology. When I did some of my general medical training involved haematology, I realized it just fitted. I was very interested in the kind of complex cases that you see, but also, particularly in those days, haematology also involved diagnosis. So you would actually take the biopsy and look at the biopsy yourself under the microscope, and that just all appealed. And then I did an overseas fellowship, came back, did a PhD, and then a very seismic move for me, which was to move to Australia because I'd married an Australian, a Queensland girl. It was also a very good time to move to Australia because there were a lot of jobs in the UK, so if things went wrong, it was a good time to come back. I knew I'd be okay and land on my feet. But I moved here on an overseas fellowship. The idea that I told people was to go back and use skills I've learned. I obviously haven't done that yet. And I also got a job at the Princess Alexandra Hospital, where I still work clinically. It was interesting because I didn't have a proper interview. I actually had a cup of tea with someone, and she said, "Would you like a job?" And yeah, no HR people in the room at all. It was great. And I also worked here at the QMR as a postdoc, and then became a laboratory head. Then moved to the TRI and became the Leukemia Foundation chair of blood cancer research, and subsequently moved to the Mater as executive director. But for the purposes of this talk, what was really important is this period here. So I'd already decided that there were problems with my specialty, fairly obvious because we had limitations. A lot of people weren't doing well, and even the ones who did do well sometimes in fact, quite often had very lifelong disability because the treatments we gave were untargeted. And during this time, a lot of exciting developments happened, including sequencing the genome. This would all happen in the late 90s and early 2000s. And I was exposed to some very, very clever people, particularly in Toronto, the Princess Margaret Cancer Centre, where I did my fellowship, and in Cambridge, where I did my PhD. So I could clearly see the potential of precision medicine to develop treatments that were more efficacious and would be less toxic. And that is all true, but it's not the whole story, because the real reason for me becoming a clinician scientist is because I had finally found my tribe. Okay, so what is a clinician scientist? It's not really a very complicated definition. It is people who combine a career in clinical practice with a career in research. It covers all categories and all specialties, and there is no single defined training pathway. Why be a clinician scientist? Well, this is just my own personal take on it. You are contributing to the evidence base. As a good clinician, you should want to contribute to the evidence base, and you should want to perform best practice based on that evidence base. As a clinician scientist, you can leave a legacy beyond direct patient care. Not that I'm in any way saying that direct patient care isn't incredibly valuable. Of course it is. It is also an incredibly intellectually rewarding career. And in part, that is because of the way that you think as a clinician scientist, in contrast to a clinician, and taking an extreme example, the clinician who works as an emergency doctor, where things are constantly coming through the door and you're having to react, which some people love. It gives them an adrenaline buzz. Whereas what you're doing as a clinician scientist is very strategic. It's very long-term thinking. You have to define the clinical problem, the global clinical problem, but then the small bits along the way that you can contribute to try and answer that, and how you will do that. Not only how you will do that in terms of designing an experiment, but also how you're going to fund it and who you're going to hire. It's actually a very long-term process that I personally find it suits me down to the ground. You will also get the opportunity for international travel and to meet like-minded colleagues, some of whom will become lifelong friends. And it's an incredibly exciting career. Why not be a clinician scientist? Well, there is no defined career pathway, and that is actually not only very challenging, but I think it affects the other two dot points, clinical and scientific credibility. Because I think for a lot of people, including at one stage, someone who is head of my department at the Princess Alexandra Hospital, who said to me, "What is a clinician scientist?" That they don't even know that we exist, because there is no defined pathway. So not only do we lack clinical credibility because we're actually spending a lot of our time doing something else, so we can't have a full breadth of our specialty, but only a particular niche area. But also, I think they don't really know what we do. Similarly, though, I think scientists look at us, again, as not a real thing, and so they don't think we have proper street cred because we don't have their scientific credibility. But nor should we. We're clinician scientists, and that's what we do, and we should be proud of it. Salary, well, that's a slightly vexed one, I think. It depends where you're looking. So if you want to make money and you're a clinician, you are better off being a plastic surgeon in private practice. Of course you are. But we all make our decisions about what motivates us. If you want to do, you're more service orientated, then you'll probably have a career in public medicine, the GP in public health, or in a public hospital rather than in private practice. And a lot of people combine both. That's fine. There is no defined career pathway, as I said, and for a lot of people, they don't have dedicated time within hospitals, and particularly don't have dedicated time if they're GPs to do research. So they're going to have to either do that themselves in their own time, or else they're going to have to take a pay cut in some way or other. If they have a fellowship, they're still taking a pay cut because the fellowships don't pay as much as their clinical salary. So you're not doing private practice, but you're also earning less, often, not always, to your public full-time counterparts. But as I say, that is very, very variable. But then on the other hand, you do get some jealousy from the scientists because you're actually earning more than them and they feel very understandably that they're undervalued. And then there's the issue of job security. You don't become a clinician scientist if you want a 9-to-5 job that you'll have for the rest of your life. There is a lot of job insecurity. If you're on fellowships, there tend to be 5-year duration, whereas if you work private practice, there's no such thing as tenure, but you're essentially always going to be employed. If you work in a public hospital, you have tenure. You do, however, have some job security because if things don't pan out as a clinician scientist, you can become a full-time clinician. And that's very nice. And that's something that we have that our scientific colleagues don't. And I really feel for them. And then there's the workload. And look, a lot of people work hard in a lot of different fields of life. Of course they do. I don't want to say we work harder, but I certainly think we work differently. I think the very nature of being a clinician scientist means you're more likely to work early mornings before those 9-to-5 hours. You're more likely to work in the evenings. You're more likely to work at the weekends. But there are some advantages as well. So my wife's a full-time clinician. When my children were very young, it was myself who could be a bit more flexible. And, you know, if someone was ill, I could drop things if it wasn't on my clinical days and then and go and see to that child. So there were some advantages as well. I do think we work harder, but I know that some people might challenge that, and it depends what specialty you do and how hard you choose to work. But perhaps the difference is a clinician is, certainly if they're in private practice, they're choosing to do that. They're choosing their workload. I think we're actually doing it in part to survive because we have to publish in order to get that next fellowship. The other thing is bureaucracy. Now, whatever you do in Australia, there will be a lot of bureaucracy. As a clinician, there's a lot of bureaucracy. But as a clinician scientist, you have that clinical bureaucracy and you also have all the research bureaucracy. And this really has increased. And I don't think I'm alone in saying that it's actually sucking the fun out of it all. It's not just slowing you down. It's not just preventing you from doing some good in the world. It's actually taking away, I think, some of the gee whiz factor out of it all. But for me, I made the right decision. I'm absolutely certain about that. And if there was one single bullet point here, it was this one. It was exciting. And that's what I hope to try and bring out when I talk about a few career highlights. In order to do that, I need to tell you what I do. So I run a blood cancer research group, and we have a clinical focus in lymphoma and a biomedical focus that you don't need to understand, but we're looking at something called the tumor microenvironment. And we put the two together and translate that into investigator-led clinical trials that we hope will be chemotherapy-free. So there will be targeted agents, and a lot of those target agents will be immune-based. And initially, I made my name in Hodgkin lymphoma, but subsequently moved to look at other forms of lymphoma as well. So highlights along the way, and I'm going to subdivide these because I want them to illustrate a point. So the first thing is the indirect highlights. They're indirect because if we put patients at the forefront of everything, which I think you should as a clinician scientist, then the impact on the patient was indirect. So these are scientific discoveries, and they relate to what I mean by that gee whiz or that exciting thing about being a clinician scientist. And then there were the direct impacts on patients, but direct impacts on patients that only a clinician scientist can do, not a conventional clinician, because you're doing something that helps a patient that only you have access to. And I'll explain that in a moment. Sorry. And then we have putting that all together in terms of clinical trials, combining the indirect with the direct. And lastly, I'm going to talk about the next generation and legacy. So just a few highlights. It does not matter at all about the data on here, but this was something I did as a postdoc that still to this day gives me great satisfaction because we identified a molecule, and I say we because it was a team, and actually the brains behind the team was a senior author, not the first author. But we identified a molecule called LAG3, and we found that it was immunosuppressive. It was the first immune checkpoint in any lymphoma that was ever identified. And if you prevented the function of that molecule, you could actually reverse that immunosuppression. It's been cited in 3 global patent families, and there's currently 97 current clinical trials in the world based on that. That's a fantastic outcome that still gives me a great deal of satisfaction. And another one with this description of what we call hot and cold. By hot, I mean that some tumors are inflamed, so they contain a lot of immune cells. Oops, I think this must be on some kind of automatic loop. And some other histologically identical lymphomas actually contain very few immune cells, so they're immunologically inert or cold. And you can see in the blue line that the cold ones do poorly compared to the hot ones. So in other words, the immune system is actually having an effect on patient prognosis, which actually has clinical implications. And finally, the last G with one is to take a lymphoma that had been well defined and actually define a subgroup in it that then influences the way in which we classify the World Health Classification of lymphomas. And again, you really don't need to understand this except to look at the blue dots. And there was lots of blue dots on the left and not a lot of blue dots on the right. And what that means is on the right, we have a new kind of lymphoma, even if it looks histologically identical, in other words, identical under the microscope as the ones on the left. What this means is not only do they have a different molecular biology, but they can be treated in different ways. Which leads me then onto the direct aspects of being a clinician scientist. So here we have a patient called Susanna Scott, and I'm allowed to say her name because she's agreed to be identified, agreed to have a photograph. And what she's receiving here, which you can see in the black circle, is the very world first vaccine for that particular indication, which was a brain lymphoma that was virus driven. And she had failed 2 prior lines of therapy, and she was actually unconscious at the time. So we had to get the permission of her uncle. Now, this is not a very subtle slide. This is the brain lymphoma on the left. It's all the white bit and it's gone on the right, apart from a little bit of residual scar tissue. She's alive to this day, nearly 20 years later. So that was a very rewarding thing to do, obviously, but it's also had follow-on implications that I'll allude to later in terms of clinical trials. And here is another one of those direct gee-whiz moments. This is Katie Pulling, again, agreed to have her name and identity displayed. She's here with members of the lab team and members of the clinical team and her parents. And it was a world first because we discovered a condition that had never previously been identified. And when we figured out the problem, we cured it. And she'd been having this problem for the whole of her life. And we cured it when she was about 20. So again, a very, very rewarding, direct patient contact. And then the clinical trial. So these are 3 current clinical trials that I'm the lead investigator on that are funded by the MRFF. And they all involve cellular therapy in combination with something else. It could be a small molecule, it could be an antibody. And in one case, it's actually sequential therapy where patients get chemotherapy and then they get something called a CAR T cell. The first study, Trouble 1, has now stopped accruing and we're in that sort of follow-up phase. And the other 2 studies will start this year. And they're multi-center studies that are being performed all over Australia. And now a very satisfying slide indeed. And this is the next generation, laying foundations for the next generation of clinical and translational scientists. And I shouldn't have favorites, and I don't, but I will single out one person, Michael Green on the far right, because he's an absolute superstar. He's really one of the world's leading scientists in his field. He runs a lab in the MD Anderson, and to have been involved in the early stages of his career is, without doubt, for me, a career highlight. And then we have Colm Keane, who runs his own group in the UQ Fraser Institute, and was with me for, I think, about 12 years from the early days. Karthik Nath, who finished his PhD a few years ago and now runs his own group in Memorial Sloan Kettering. Josh Tobin, he's not quite running his own group, but he's effectively running my group. I think he's my 2IC. I've mentioned him also because a very satisfying thing, he's recently come back from Michael Green's lab. So you're sort of seeing this virtuous cycle where someone's been mentored and then mentoring the next generation of people as well. So it's a very, very satisfying thing, which leads me nicely to almost the last slide, role models and mentors. So I wasn't part of the generation that had formal mentorship programs. And I do think we lagged behind our professional colleagues in engineering and in law and in other professions here who have really well-defined and really good mentoring programs. But these were people who influenced me along the way, and they're very different. They're different people with different strengths, and they're very different because they influenced me at different stages of my career. But what they have in common is that they influence me. You'll have people who are currently influencing you and people who will influence you in the future. And the point I'm really trying to get at is it's not just about the mentors. It's about you as mentees and what you bring to the table to try and understand what their strengths are and how it can influence you to be a better person and a better clinician scientist in the future. So finally, my tips. Choose the right research environment for you. Obviously, you might be at a career stage when you've got a family. Children are not easily portable. For financial reasons, you may not be able to move around. I get that, and I don't get why this keeps moving. Okay. Also, you know, not everyone can go overseas and do a fellowship and go to Stanford or to Cambridge or wherever. And it might be that your own specialty actually is better if you're interested, for example, in regional health, in working in a regional area. But give a lot of thought to where that environment is, because it's not just what you learn directly from your supervisor, it's all the things that are happening around you, but it's also about what you bring to the table and what you choose to learn from the people around you. Don't compromise. Seek and strive to achieve excellence in what you do. Speaking as someone who came to Australia in 2003, it was so obvious to me what tall poppy syndrome was about. People were constantly talking about what was happening overseas, particularly in America, but also in Europe, as if somehow it was amazing. And it was amazing, but there was some great stuff happening in Australia as well. Don't do yourselves down. Don't do Me Too research. Do research that's the best, plan it well, and really go for broke. Don't sell yourself short. And then be curious and be open-minded. And I have seen people who are very clever, but have got very close minds and are basically spending their entire career trying to prove something, even when maybe the evidence is suggesting something different. Don't do that. Be open-minded, learn how to work PowerPoint. Okay. You are going to be time poor, so spend time on your project management skills, and you're going to employ people. And the most important resource anyone has in any business is people. So hone your people management skills. Develop networks and collaborate, because you can't do good research in isolation, and work with people who have non-overlapping skills who can bring something to the table. So they might be working in a different field. So for me as a hematologist, I need to work with people who understand public health, people who understand health economics, genomics, immunology. I need to work with nurses. I need to work with a lot of people to answer particular problems, and they need to work with me. Collaborate and work hard at those collaborations, because good collaboration is actually very hard. And finally, we all have the stories about people who are complete psychopaths who get to the top. Well, yes, it's true, but they do cause a lot of carnage along the way. There's also a lot of people who are very decent and are very good and behave with a lot of integrity in what they do. Be that kind of clinician scientist. So good luck in your career with whatever you do, and thank you very much.
Please don't run away. You've been treated to two absolutely stellar opening addresses here today. So Maher, that was just fantastic. Some wonderful lessons and observations along the way. Before I jump in questions, I do want to ask, has anyone out there got any kind of question? I thought hands would go up. There's 1, 2, and then 3. So we'll start with those.
So my question is, what sort of stakeholders are you communicating with?
Yeah, I think the question was really about how you choose your stakeholders in order to communicate the work that you do. Is that a fair paraphrase? So that's actually a very, very good question. And I would never have thought of that question. I don't know what stage of career you're in, but it only was something that I started thinking about relatively recently in my career. So that's a particularly good question. And for me, it works in two ways. So one, I'm working with a clinical trials collaborative group. So my stakeholders obviously are the patient, but also clinicians, because they need to communicate the discoveries in the clinical trials to accrue patients to that broader group. And we do have very, very strong consumer engagement. Because I did have that role with the Leukemia Foundation, I have been very lucky. In many ways, I've been given consumer engagement on a plate. Although I don't have that role anymore, I have a very active role with that particular society. And more recently, I have a role on a federal task force for blood cancer. There's a small group of us, and we meet with the minister regularly once a year. And it's actually a very useful forum to talk about the things that are important to us, mainly from a clinical perspective, about sort of joining up the dots within blood cancer in Australia, particularly in those regional areas where I think patients are very underserved, both in terms of diagnosis and treatment. But also to try and talk about a research roadmap, which is really good, because if you're going to do things, you actually need to start planning it many years in advance and ensure that the right funding levers are in place. So it's a great question. Thank you.
There was another question over here, and then there was one. Yep.
Yeah, so I think the question was principally about clinical credibility and how you deal with that. And that's not an easy one, because I think it partly depends on how much time you want to spend doing your research. If you have to accept that any time away from the clinician will, over a period of time, make you a worse clinician, but also accept in some ways it'll make you a better clinician, and it will make your colleagues benefit as well. They will value you because you can answer certain things that they can't, or at least get them to start thinking in a particular way. You will work in a group, some kind of group, let's say it's a hospital department, then you will contribute when you do your journal club or your educational session in a way that the other people won't. That's actually very beneficial to them. Similarly, they will be of great benefit to you. I think you just have to accept it, really. You can't do everything, but you're doing something that's actually very special and worthwhile.
And yep, there was a question there.
I was wondering what like a daily life.
Yeah, I think there are two questions in that. The first one is, what is daily life like as a clinician scientist? And the second one was about evidence-based, which I assume it would be evidence-based about clinician science and its status in Australia. So with the first part, so a lot of my time now is actually as a research administrator. And so I was being slightly disingenuous with you when I talked about clinician scientists in terms of being reactive versus being strategic. As a research administrator, part of your time is actually being reactive, because there are little fires that pop out, and often these fires are human resource type issues, or actually are financial. So you have to deal with them, but you're also, as an administrator, strategic. You're thinking about the long-term thing. You have to develop a strategy whenever you come into that role over 5 years, and you have to refresh it in the subsequent 5 years, and so on. So that's part of what my day looks like. I tend to have what on paper is a very structured day, but then I don't keep to it because of these fires that keep coming. And I have to have a diary, and I have to have someone full-time who helps me with my diary, because there's quite a lot of things to do, which is good because you can get a lot done, but it sometimes takes fun out of things, because it is nice to be a little bit more spontaneous, and that's been taken away from me. The only thing that's ring-fenced is my clinical time, and that's my happy space, to be completely honest. And that's my happy space in part because I'm with patients and I really like that, but in part also because I can blot out some of the other stuff and do things uninterrupted, and people do tend to leave me alone when I do that. In terms of the evidence base, my understanding is that in Australia, there aren't a lot of clinician scientists. They've come at it from lots of different ways. Only about 2/3 of them actually have a research higher degree, which I find very interesting. Very few of them will actually have protected time as part of their clinical work, but usually they're having to do it in some other way. There are many different ways. In my own kind of background, which is working in the research institute sector, it usually means you have a part-time position as a clinician, and then you have a part-time position, which is often fellowship funded to do your research work. I think that's what a snapshot of clinician scientists are like in Australia. And I think it's very, very different in some other countries. I know what the American and the Canadian models like. I'm very well aware of what the UK model was like, but it's changed a lot over years. And I actually think the way it's changed is much better than the Australian system. I don't think we actually have a system in Australia yet. Thank you.
Other questions from folks? Yeah.
How do you translate findings into the clinic, which in the example given, I think was in terms of a product, but it doesn't have to be, it could be a research finding in terms of a maybe a diagnostic, for example, or some kind of evidence-based practice that might change things. It's a difficult question to answer because translation is actually very broad. So if you discover a vaccine and then license that vaccine and retain some of the intellectual property, and I use that example because it's obviously a Queensland-centric example, then you're actually doing a great service in terms of translation, but your service initially is making the discovery. It's actually then a company who will translate that finding, and they're largely driven by a commercial factor. Another way in which you can translate a finding is that you advertise what you're doing by getting it known in various forums, getting expertise within your skill set, which means that what you say is likely to be listened to and likely to enter clinical guidelines. Now, a lot of clinical guidelines aren't actually used, which is interesting, but it is the first place to start. That is the evidence base, and people may not use them for lots of different reasons, sometimes because it's actually impossible for them. They may not have access to that drug or diagnostic, or it might be that they're unaware the guidelines are buried, whatever. And another way, I think, is working with industry to do clinical trials where they provide you with an agent, but you provide them with the vehicle, the clinical trial, in order to use that agent. So there are many, many different ways to get what you do out there. And I suspect things evolve, the number of ways in which that's going to work will increase. But I think what's really going to increase is working with consumers. And I actually don't like the word consumer, but it is what it is. It is working with patients, or, I mean, if you're working in a setting where I do, where many of those patients may not, be around in the long term, it's actually working with their carers to act in, I suppose, almost as lobbyists to try and influence management within Australia. I hope that answers your question.
Now, there was one more flicker of a hand and then we'll break for morning tea. So yes, up the back there.
I think the question was, what is the role of doing a PhD either before you enter medicine or doing an intercalated MD and PhD, as opposed to the more conventional route of doing a PhD at some stage after you've already got your primary medical degree. So the career paths are even more complicated than that, because when you do that PhD can vary considerably after you've got your initial qualification. So my research institute, we have people who are eminently qualified clinically in terms of they are running clinical departments. In some cases, they're actually department heads, but they're also doing a PhD. So they're senior in one domain and quite junior in another. And then we have people who increasingly are doing PhDs to make them more competitive to get onto an advanced training program, because there seems to be a bottleneck there at present. and you have people who interrupt their specialist training, which is what I did, to then do a PhD and then come back and complete their specialist training. So not only does that have implications in terms of the kind of training you get and where you end up, it also has financial implications. It has life implications, and I alluded to family. It's actually a very important fact. Of course it is. I mean, family is central to everything that we do. So there shouldn't be one definitive answer. We should have a multitude of pathways, but I think we should have one typical pathway. I think that makes it easier for all of us. Personally, I think that typical pathway should be at the same time as specialist training, when people are given an option to become a clinician-scientist, clinician researcher, and have an intercalated program, which takes a bit longer. And I think that is the optimal pathway, because then they have already decided what disease or specialty they're particularly interested in, but they're saying that they want to do that in a more academic sense. I think doing your PhD before you do medicine is often somebody's route to getting into medicine. They may not have done that deliberately, but it is someone's route. They haven't done the PhD and then gone into medicine and with the view to being clinician scientist, and they often end up doing something different. And I think the skills that they learn will still apply as a clinician scientist, but unfortunately, the funding avenues we have actually make it quite difficult for them, because the clock will start ticking from either their PhD or their primary degree. So actually, you're more competitive if that clock will start ticking only relatively soon after you've got that degree, because you're more likely to be, relative to opportunity, competitive to get a fellowship, for example. If you do a PhD during your MD, which I know the universities like it, let's be honest, it's a money-making cow for them. It really is. It doesn't mean it's a bad thing, but that is it's a financial driver for them. I've had MD PhDs in my lab. I have one at the moment, actually, and I've also had MD MPhils in my lab too. And it's too soon for me to know exactly how they'll do. I know the first one went and did something quite different, but having that MPhil was very useful for his career. So I've no doubt, he still keeps in touch, I've no doubt it was useful for him, but I don't think he will be a clinician scientist. And with the others, it's too early to say, but I personally think that the load is too hard. I think that you, once you finish the laboratory phase and you're supposed to do your write-up, I think you get caught up by getting your exams and then becoming a junior doctor. So one of them became a junior doctor, and his first stint was in far north Queensland, and he thought he'd have time. He had no time. He did everything was out of hours, was clinical, because he felt obliged as one of the only people there with clinical training to do the work. So he's had to ask for special leave from his PhD in order that he has a bit of extra time to do it. So I personally think you've got to be exceptionally motivated, and the project's got to be extremely defined and essentially smaller, shorter, and easier than a conventional PhD if you're going to do that route. Thank you.
So look, we might cease there because we will have some morning tea. So please join me in thanking Maher for a fantastic presentation. And I would have to say, I think what you can see and observe from our two speakers today is that communication skills are also paramount for success. I would say that these two people are exceptional in what they do, but they have a clarity of their expression and thinking, and that really does help in research, I have found as well. Being able to communicate, summarize, and persuade, if you're trying to ask a minister or a hospital director to change practice, those skills of communication. So I would encourage you, in addition to all your scientific training and your clinical training, think about how you communicate and really work on your communication skills, because I would say that is one of the hidden gems that really identifies the successful people in a research career. That if you can communicate your findings or communicate your ideas, you'll get funded. If you can communicate your findings, you'll get published. And if you can communicate the summary of those things, you'll change practice. So communication is key as well. And I think you've heard two fantastic communicators here today. So let's conclude this very first session. Please join me in thanking both of our wonderful speakers one more time.